Alright, gentlemen, today we're going to talk about classifying matter. And our overall mission, our goal today, is to determine how to classify matter. Basically, what are we looking at? There are two forms of matter, pure substances and you have mixtures. It's important today, we're going to move pretty quickly, so you might want to pause and rewind at certain times to make sure you keep up. First, we're going to talk about pure substances. Pure substances contain only one type of particle. Okay? It could be an element, where you have one type of atom present, or it could be a compound where there's only one type of molecule present. So for example, here on the left we have platinum, right, that metal rock, an atom, an element with an atom, and on the right was water. It was a compound. Mixtures now are a combination of two or more particles. They can be homogeneous, so have one phase, sort of that uniform appearance that you see here. There's no split. Or they're heterogeneous here on the right, and they have two or more phases. So you have a very obvious split. As you can see here, there's the liquid phase, your boundary, and then the solid phase. Okay, so that's your difference. The pure substances, that one type of particle, an atom or compound. Here you have mixtures with multiple types of particles. Homogeneous mixtures specifically, the big question is here, does light pass through them? If it does, you have a transparent mixture, and it's either a solution or a colloid. No, you have an opaque solution, and it's either a suspension or a colloid. And we'll talk about when you know, how do you know whether it's a colloid or a solution. But for the most part, usually if it's transparent, it's often a solution. If it's opaque, it's often a suspension. Okay, here's an overall chart of sort of the path to follow to determine what type of solution, or sorry, mixture you have. So this first thing is, does it have one? First question is, does it have one or two phases? If it has two phases, it's heterogeneous, and we call it a mechanical mixture. If it has one phase, we call it homogeneous, and then we ask, can light pass through? If yes, it's transparent. We're going to do something called the Tyndall test. Basically, you're going to shine a laser through it, and if it scatters differently than it would in a solution, so there's more scattering in the colloid, you would get yes. If you get funny scattering, when you use the Tyndall test, you get a colloid. If no, it is a negative result for this Tyndall test, you get a solution. On the other side, you get an opaque solution, so no light can pass through it. You ask, can it be separated by centrifugation? And that's where you spin it really, really quickly, and you see if you get two things separating out. So if you centrifuge it, does it become a mechanical mixture? If it doesn't, you have a colloid. If it does, you have a suspension. Okay? There's one last type of mixture to talk about, and that's an alloy. These are solutions of metals. They're homogeneous mixtures of metals. They appear to be one type of metal, but contain multiple types of particles. Right? So here you have bronze, which contains copper and zinc. In the middle here you have stainless steel, and on the right, brass. So these are examples of alloys where you have multiple types of metals, bonded or mixed together to create this solution of metals. Okay, so some of the key terms we talked about today: pure substances, mixtures, elements, compounds, homogeneous, heterogeneous, solutions, suspensions, colloids, mechanical mixtures, and alloys. I would add all of these things to your key terms list. Okay? Specifically, before we go on, I just wanted to talk about solutions. I think you have probably touched on this before in other classes, but just to be clear, a solution contains a solute dissolved in a solvent. We'll go into a little bit more depth about that in class, but I wanted you to remember, sort of remind you here, solutions have solutes dissolved in solvents, but again you have those two different particles mixed together to get that homogeneous phase. So if you need to watch this again, feel free. Make sure you're understanding all these key terms, fill out the key terms page, as well as take those notes. Answer the question on Verso, and come to class ready for a quiz. Okay?